after we cover those things, the algorithm library, do namespaces, and then after namespaces, just review any topics you guys still have questions on. Yeah. Oh, what seed is? I thought you said C. I'm like, the C language. I'm like, oh, okay. So sure, the seed for the random number generator is a value used to initialize its state. Let's keep the conversation down. Thanks. So the example that I gave the other day, and like an easy way to think about what the seed does. Get back out. Okay, so about the seed. The easy way to think about, so what the seed does is it initializes the random number generator state. The state is what the random number generator uses to both, one, get the next random value from the stream, or compute the next random value in the sequence, and two, to transition to the next value in that sequence. A nice way of thinking about it is that each of the random number generators is capable of generating some sequence of random numbers, and the seed tells you which of these sequences of random numbers to pick. So one seed might set you on this stream of random numbers here, where the first value is 1, then -3, then -3, then 65, and so on. A different seed, maybe say 7, puts you on this stream of random numbers. And then say maybe 85 puts you on this stream of random numbers down here, right? As long as you seed it with that same value, you're going to start at the beginning of that stream of random numbers. So if we seed it with 85 again, we're going to end up at 45. If we seed it with 85 again, we end up back here at the beginning of this stream, 45 again. And we get that same sequence of random numbers every single time. Does that make sense? Yeah. Why would you have the same? So the question is, why would you want the same sequence of random numbers? It's super helpful for when you're testing. Right? So you probably want to use a constant seed when you're testing so that you get consistent input. It would be really annoying if you were trying to debug your code and sometimes it would break and other times it wouldn't break, and whether it broke or not was just some random coin toss. Right? Finding that bug really hard. But if you set the seed to be constant, you get that same sequence of random numbers, so it would always break at the exact same time in the exact same manner. When you would go to release your product though, or your code, you would probably seed the random number generator with something that wasn't constant. Very common. It's very common to seed it with the time, because the time will always be different. So you get that different behavior every time you play the game. Or you're right, every time you played your game of blackjack or whatever, you get dealt the exact same hand every single time you played the game. Would be very interesting. Any other questions? Yeah. We will get to exceptions eventually, but not today. Okay, so the other things that I wanted to show you from the random library, or the algorithm library, are last time we saw this remove if negative. And so again, like when you do remove, it doesn't shrink the container at all. What it will do is, yes, it will remove those elements, but it kind of like puts them to the back of the container. And it gives you an iterator to the new end. So you'd have to erase to shrink back down. And, technically what the values are that get placed at the end are undefined. So there's something there, but I have no idea what they're going to be, and you shouldn't be using those values. So over here, when we wanted to remove the 55s, here's what the stream of numbers was before removing. So you can see we have a couple of 55s in here. After we remove the 55s, of which there are 1, 2 55s, right? The last two values here are like not good to use. Right? Notice they kind of like moved over here as well. They're double copied now. But after I erase, because my new end was pointed to be right here, after I erase down to be that new end, I only have the correct set of values. So be really careful with that. Does that make sense? After you erase the elements, they're still technically the same size. So even though we removed 5 things from our 10 element vector, or removed 2 things from our 10 element vector, there are still size of 10 until we erase back down. It's just those last 2 things are not good values. Yeah. I'm not sure why it's not automatically handled and shrinking back down. My guess is to potentially make it more flexible, but I'm not sure. Like for example, sometimes you could do what's called like a lazy deletion, which is what's happening here. So the elements, like, we're not actually shrinking down, but we wouldn't consider those elements to be a part of our vector anymore. This would allow us to do the removals a lot faster and potentially save some time. It might also be useful to not shrink us down if we plan on putting something in that space in just a little bit. So it provides a little bit more flexibility. If you want to actually shrink down, you can shrink down. There's also a remove if function, which takes in a vector, again, like a sequence, a beginning and an end iterator, and then it takes in a function that takes one argument, and that argument should return true if you want to remove that element and false if you want to keep that element. So here we're able to remove all of the negative numbers from our vector quite easily. And then again, we still need to shrink down because just like with the normal erase, the elements are kind of like shoved to the end. So you can see here, before we remove the negative numbers, those negative numbers are there. There's 1, 2, 3, 4 of them. So after we erased, like, these 4 elements aren't going to be considered a part of our vector anymore, right? So our new end that we would get back from erase would be referencing this position right here. Then after we do remove, then after I erase, these 4 elements get removed, and we're just left with all the positive ones. You can also copy values. When you do the copying, you say, again, some range to copy over. You then give an iterator where you want to add the elements at. And then you say, well, what's the condition on which you want to copy? So this one's only going to copy the negative values. You can also see here I use something new. It's called a back inserter. A back inserter produces a new iterator that would cause you to insert into the back of this container. So I can create a new vector to hold my values. I create a back inserter over this vector. So every time I go to add something using this iterator, it's actually going to push it to the back of my vector. So I end up with just the negative numbers in this copy. Yeah. How is it different from push back? So the back inserter does call push back, right? But the copy if function requires an iterator. So I have to give it an iterator who takes the value and pushes it back. If I already had the space like declared as to where I wanted to add it, I could pass a vector over to, or it could pass an iterator to the beginning of that space that I want to add it to as well. So if I had created this vector over here and I resized it to be at least the same size as vector, I could just have passed in only negatives dot begin. And because then I would have made sure that I had enough space to fit everything, and I could shrink back down to the end to fit only elements that I needed. So this is just a lot more convenient way of doing that and not having to worry about it. Any other questions about the back inserter? If you want to be able to use the back inserter, you have to include iterator. Then the other one that I have over here is the add one printer. It uses transform. And so what transform does is it transforms a range into some new range. So again, you give it the range of elements that you want to work on. You give it an iterator as to where you want to add the values to. And then you give it some function. This function should take in a single element and then return the new value that you want. So what I did right now is I copied all of these elements into this vector called one more. But if I really wanted to change the original range, what I could have done is down here, instead of passing in this insert iterator, I could have passed in vec.begin, and then all of my elements would have been updated to be one more than what they were previously. Add one is just a simple function. That just, turns one more. So now you can see down here, we have every element, but one more has been added to it. But notice that this range of values that I have didn't change the original. I put them all into a completely different vector called one more. If I wanted to put them in the original, vec.begin. Any questions about any of these methods? Yesterday, somebody asked about, is there any method that removes duplicates? And so you might come over here and you might be like, oh, hey, unique. That looks like what I might want. I want all the unique elements in that range. It only removes duplicates that are next to each other. So if you had like 5, 10, 5, you'd still get 5, 10, 5 back. But if you had 5, 5, 10, then you'd get 5, 10. So only if the elements are next to each other, duplicates that are next to each other, does it remove. We will talk about a little bit later how we could write our own function, probably more like a functor, that could actually remove all the duplicates from a range, but it's a little bit more complicated, and we have to talk about user-defined classes first before we can make that happen. I really recommend that you guys do look through the algorithm class. There's a lot of useful things there. Read through the documentation on each function, and also read through the examples to understand how they work. It can save you a lot of time because there are a lot of really common tasks that are defined inside of here, so that you don't have to keep rewriting that same code. Any questions before we move to namespaces? Okay. So this is a question you guys have been asking about for a while. So let's start with some motivation. Let's imagine you're working on a problem, right? Some project where you're trying to solve some problem. You're actually not in school anymore. So what you do is you search online to see if anybody solved that problem before, which is what you should do when you're actually in an industry. See if somebody's already done the thing. And let's say you find someone has already done this thing and it's perfect. They have this exact library that does exactly what you need. You download this library and now you try to include it inside your solution. When you now go to compile, you find that the person that wrote this library, they just so happened to have used an exact same name of the function that you did. And so now you end up with a double definition error or a multiple definition error. Well, they're kind of screwed because you can't have this in your code. So what you'd have to do if you really wanted this project to continue to work with yours is go rename all of your functions to be something different, which might be really sad because you may have picked out some really good, nice sounding names for your functions that make a lot of sense. But if you wanted to use it, this would be what you'd stuck with. Well, what do you think is easier for you to change? The code that you borrowed, right? Or the code that you wrote? What do you understand better? My code, right? So it's probably easier to change your code than to go to change somebody else's. A bit safer as well. It may also be that that library is pre-compiled, which is the next thing, is again, if we had a pre-built library, we can't actually modify any of their code at all, right? So we'd have to change ours. But even worse is, let's say that you now needed 2 separate projects, and those 2 separate projects both happen to use the same name. Now you're really screwed if they're pre-built because you can't change those pre-built libraries. They're already been compiled. And so you now have to pick which one do you want to use. So this problem is called name collisions. 2 different symbols that mean different things happen to have the same representation. It's when you keep reusing that symbol. This could be like the name for a function or the name of a type or a class name or a namespace. It can be a really tricky issue to avoid, especially when multiple outside projects that you have absolutely no control over are going to be integrated into your project, because the same name might make sense in both contexts. For example, there might be like a log function, right? You might need to use a log function from the math library that computes the logarithm of some numbers, But you might also need to use some log-like software that logs your output to a file. This can even pop up in the same project if you and somebody else are both working on it. You might accidentally choose to both use the same name, but you're kind of more or less working on two independent parts of that project. So what namespaces are, they're a way to confine symbols to a specific scope so that you don't end up with name collision. It makes it so that these symbols only appear inside the scope and they can't get out to the global area. The syntax for doing this is namespace, which should be in lowercase, and then you do your function definitions, declarations, and any other code that makes sense to go inside there. So I might create a namespace called MySpace, and inside it I declare a function called myfunction1 and myfunction2, and so on. Any questions about what the purpose of namespaces is for? Like namespaces create like a box that contains symbols, and those symbols can't get out of that box. So now if we have two separate boxes, right, where you happen to use the same name and I happen to use the same name, if our names are in separate boxes, they can't get out, so there's no problem. We won't have that multiple definition or declaration or redefinition errors. Yeah.
So it's like variable.
Or are you thinking about like variables inside of a class?
Yeah, like
yeah, like local variables in a lot of ways. It makes these symbols local to that scope. It's a really good way of putting it. So we'll show you how to do that. But yes, you start your namespace declarations inside the header files. But they might show up in your CVPs as well, depending on how you write it.
Or should they be on those certain functions? Let's do it on function.
Yeah, so they can also be used for like modules as well. Like I want to collect all of these names into some kind of space. For example, you've seen namespaces with the standard library, std, : std is a namespace, right? And they've collected everything that's related to the standard library in that namespace. Also, when you create classes, they create their own namespace. So there's like a vector namespace and a string namespace where we're able to like keep all those symbols contained inside of strings or vectors or whatever else. So your namespaces can extend across multiple files, right? Just like you're asking for like a module. If you had multiple header files that made up a project, you'd want to make sure that you put them all inside the same namespace. So like here's file 1 and file 2, and they both have, you know, the same namespace, MySpace. So still one logical space. Both of these files contribute to it, file 1 and file 2. Of course, you can nest namespaces if you want to. Happens kind of frequently if you have a very big project with lots of subparts in it. So you have some namespace, maybe it's called outer space, and inside of it we define foo, and we define bar. And then we also have another namespace inside of it called inner space, where we define another symbol named foo and another symbol named bar, and we also defined another function called car. This is perfectly legal and perfectly fine, even though you can see that there are two different foos, right, that have the exact same signature. It's fine because they're in separate namespaces. One's in inner space, one's in outer space. And technically the one in inner space is in outer space, inner space. Yeah?
So you have two MySpace.
So these are just considered to be part of the same namespace.
The same file?
They're not part of the same file, right? They're in two separate physical files, but they are logically considered to be in the same namespace. Yeah. So name collision is if you happen to use the same symbol, which like a symbol could be something like a variable name or a function name, right, in different ways where they'd happen to match. So for example, if I define a function called foo and you define a function called foo, we might not have a namespace collision because our signatures are exactly the same, right? And so when I call foo, should I be calling your foo or my foo, right? There's a conflict now and the compiler can't resolve it. But if we put, you know, my foo inside Matthew's namespace and we put your foo inside your namespace, now we're fine because they're contained inside those different containers. Yeah. Yeah, we'll get to that in 1 second.
And if the spaces are have the same name, how would it resolve?
So if you have the namespaces that have the same name, they're considered part of the same namespace. Right? So you can think about like this namespace contains both the code inside of file 1 and the code inside of file 2. Like you smush them together, even though they're logically split across two different files. So when we go to do a symbol lookup, we first search inside the current namespace. If we find a match, we'll use that symbol. If we don't find a match inside this namespace, we look inside the enclosing namespace. If we find a match there, great, we use it. If we don't, we look outside that namespace. Find a match, great, we use it. And if we don't keep finding it, we keep looking outside, 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 until we finally get to the global namespace. If we finally get to the global namespace and we can't find a matching symbol for what we're trying to do, that's when you get a compiler error that this thing does not exist because it couldn't find it. So over here, here's a pretty somewhat interesting example. So we have two spaces, space 1 and space 2. 1 returns 1, 4 returns 4. So inside space 2, I also happen to have a function named 1. So if over here, when I call 2, right, I look for the 1 that's inside of my namespace. So I end up using this function. So what does 2 actually end up returning? -2, right? Because we're going to use this 1 over here because he's inside my enclosing namespace. Over here in 3, when I call 4, are there any 4s inside my namespace right now? No, so I look outside of my enclosing namespace. Oh, there's a 4 in space 1. I'm going to use that function. So we'd get the value 4 plus -1, right? Because we're still calling R1 over here. It's inside of the current namespace. So we'd get positive 3 here. If I tried to call the function, say 5, I would look inside space 2. Is there a function named 5? No. I would look inside space 1. Is there a function named 5? No. I look in the global namespace. Is there anything there? No. Error. Any questions here? Yeah. Yep, we're about to get to that. So you guys have seen the : operator, and you're like, well, what does that mean, right? It's called the scope resolution operator, and it directs the compiler to look inside a specific namespace. So you do some namespace, : some symbol. If the namespaces are nested, you would do like space 1, : space 2, : space 3 until you finally got down to that namespace that you wanted to be at, and then you would list the name of the function that you'd want to use. Yeah, it's kind of sort of like a path, but it tells you what namespace to look in instead of like which directory to look in. Down over here, we'd have, so now over here again, we have 1 and 4 just like before. 1, 2, and 3 are exactly the same. But over here in 5, right, if I want to use the 1 up here, I have to say, oh, well, which one do I want? Space 1, : 1. And so now I'm going to use the 1 found inside space 1. Over here in 8, I could use space 1, : 4, space 1, : 4. And again, we're talking about this for each time. If I wanted to, I can also just say space 1, : 1 plus space 2, : 2, or space 2, : 1. And that's going to be positive 1 plus -1, which would be 0. This is just like extra. I wouldn't have to say it, right? It's a lot of extra work. And so you probably wouldn't do it when you're actually writing code. And if you wanted here to instead to say space 1, : space 2, that also would work as well. But again, it's a lot of extra typing. You probably are not into that. I know I'm not.
How would you know?
How do you know which namespace you're in? One is you can look over here and see if you're enclosed inside any of namespace. Right, that tells you which namespace you're in.
So start
That you start inside the most nested one, wherever you happen to be at. For example, this 1 and this 4 are both inside space 1. 1, 2, 3, 5, and 8, and 0 are all inside space 1, : space 2. So this is why whenever we wanted something from the standard library, which was inside the standard library namespace, we had to say std : string, or std : vector, or std : find. Go look inside that namespace, not our current one for that symbol. Does that make sense? So let's say you have your .h file and your .cpp file and you split it up. So over here we have a namespace called SomeSpace, and we declare our function 1 and function 2. If we were doing this inside of our CPP, and we need our functions to also be inside that same namespace when we define them as well, we would say namespace, some namespace, and then again declare our function or define our functions inside of there. Does that make sense? The other option, which is the one that C Lion's probably going to push you towards, is using the scope resolution operator. So again, the header file is identical, but now over here on the right-hand side, you say explicitly what space is this function inside. So inside of some space, function 1. So I'm defining the function 1 inside of some space. No, you can declare a namespace as many times as you want. Everything that you can think about it like everywhere where you use that same symbol for the namespace, they all get smushed together into be that one namespace. So if you happen to use include a project that happened to use the exact same namespace name that you used, for whatever reason, you would now bring all the symbols inside of that one namespace, which would probably be a little bit confusing, and you'd end up with the same problem we had back at the beginning, maybe. Any other questions? Right, for those of you that are kind of used to Python, you can think of namespaces sort of like a module name, right? Like when you imported math, right, and you wanted to access something inside math, you'd do math.log or math.pow or math.square root. So now we'd have to do something like, std : log, std : square root, std : whatever, to access the stuff inside the standard library. Or again, you're going to see an example in a minute of us using our own namespaces to make this happen. You don't have to use namespaces for your current project, but for future ones, I may ask you to enclose your code inside of a particular namespace, just so that you get practice using this feature. Yeah?
You could practice not working with a project?
Yeah, it's always a good, if you're just banging out something really fast for just testing purposes, you probably aren't going to be using namespaces. But if you're ever doing any serious coding, you're going to want to use it. There is one thing that I just realized right now that I forgot to put on the slides, and there's another use for the using directive. So you can also do something like this, using namespace, namespace. And what this will do is it will import all of the symbols in some namespace into your namespace. And I'm going to discourage you from doing this. So a lot of times, if you look on examples online, you'll see people that say using namespace std. So what that does is it takes all the symbols in the std library and it pulls them into the current namespace, right? So now, since all of the symbols have been brought into the current namespace, I don't need to say std anymore. I can just say vector or string or find if, right? But that's going to be polluting my current namespace and greatly increasing the odds of a namespace collision, or of a name collision. So I'm going to discourage you guys from doing this. It is possible to also only import certain names, but I need to go double check the syntax for how you do that. So here's our example with namespaces. So I have a couple of different guys over here. So over here, here's namespace 1, and he has function 1 and function 2. In space1.cpp, right, I have space 1 : fun1, space 2 : fun2, and then it just says calling fun1, and we call fun1. So again, we're making these guys over here, we're specifying that function 1 and function 2 are inside of the namespace space 1, by doing space 1 : and space 2 : When I call function 1, when I call function 1 inside of function 2, since function 1 or function 2 is inside of space 1, which function 1 will I call? Or where will I start my lookup at? In space 1, because function 2 is inside of space 1. Over here we have space 1 continue.h. So again, I used that same namespace, space 1. And so again, now we have function 1, function 2, function 3, and function 4, and they're all inside the namespace whose name is space 1. And again, they just kind of like print out their names. And then again, this is using the second option of saying how you can say that these functions are inside of a namespace when you get their definitions, by putting the name of the namespace at the beginning. Right, so again, function 3 and function 4, they're all inside of space 1 because I said namespace space 1 here. Any questions so far? Yeah. Oh, so like if space 1 was inside of like some other space, and if I wanted to do it this way, I'd have to say like namespace some other space, namespace space 1 to let me know that I was actually inside of that nested namespace. Otherwise, it would be trying to create a new space called space 1 that was not inside of some other space. Yes. So the question is it important to have a header file for every CPP file? If you don't have a header file for your CPP file, you cannot call any of those functions outside of that file. So if you want to be able to use a function outside that file, yeah, it needs to be in the header file. We also have space 2 over here. So he also happens to have a function fun1, fun2, fun3, and fun7. And again, I used the space 2 : kind of way of doing that, of finding these functions. Over here, though, notice that we wanted to use the function 1 inside of space 1, so I said space 1 : function 1 to distinguish it between the function 1 inside of space 2. Does that make sense? Then finally, over here in mains, where we bring it all together. So if I say using namespace space 2, it pulls all of the symbols from space 2 into my current space, into my current namespace. So they're all showing up in here. So now, function 1, function 2, function 3, and function 7 have all been brought into my current namespace. Over here, what namespace did I say main is inside of? Inside the global namespace. And if you want to be very explicit with the global namespace, it's just : So right now, like main and : main are the exact same thing, if you wanted to call them. This namespace right here is inside of the definition of main. So this using directive only lasts inside of main, and it will end as soon as the scope, as soon as main scope finishes up. If I put this using directive out here, it would make it global for like the entire file. What do you think would happen if I tried to use using namespace space 1 as well? Right, we'd be trying to pull all the symbols from space 1, which are function 1, function 2, and function 3, function 4 into the current namespace, right, into the global namespace, right? But notice we have function 1 through 4 defined in space 1. But we also have functions 1, 2, and 3 defined in space 2. So if I try to bring all of those symbols into the same namespace, what's going to happen? We're going to have a name collision, right? Because now we have multiple definitions for function 1, function 2, and function 3. And if you try doing that, you're going to get some errors. So function 1, function 2, function 3, I don't know which one you're talking about because of those name collisions. But now if I get rid of it, they're talking about the function 1, function 2, and function 3 in space 2, right? Because I brought all the symbols from space 2 into my current context. So here I'm calling space 1's functions. I have to be very explicit because I use the using directive. And then when I want to call the space 2 ones, since I brought all their symbols into this current space, I'm going to just say function 1, function 2, function 3, and function 7. Any questions here? Okay, that's it for namespaces. I'll make sure to go add those things about including just certain symbols into the current namespace tonight, but then we'll also just review that on Monday. So we got 15 minutes. What do you guys want to review or talk about again? Because I know there's been a lot. Yes? So you want to say using for namespaces or using for type aliases? So like the using keyword has multiple uses. One version of using is over here for namespaces, using some namespace. That means take all the symbols that are from that namespace and copy them into my namespace, whatever the current namespace is that I happen to be in, right? This is like when if you work with Python, you can say like from math import log or from math import star, right? That's going to bring in all of those symbols from that module into your current namespace as well. The other way of using the namespaces is with the using the directive to define a new type or to define another name for a type. So we can say using new type name equals old type name. So I said int vec is another name for std : vector of integers. So I didn't have to keep typing that out every single time I wanted to do that. So this is really nice to do if you have very, very long type names so you don't have to keep retyping. Any other questions about using? Okay, what else do you guys want to talk about? Yeah. So header files. What header files do, okay, first, do you know what you put inside a header file? You put the declarations, right? The reasons that you put the declarations in there is because the compiler compiles in some ways each file separately. And so to be able to call a function, the compiler needs to know either its declaration or definition, but a function can only be defined once. So if I want to be able to use these functions in other files, I need to go put their declarations into those files as well. And so what I could do is I could manually copy every single declaration to the top of that file, and then I'd be able to use it. That seems like really tedious and really cumbersome to do, right? So
the header file. I mean,
yeah, this is why we do the pound include, because what does pound include mean?
it copies all of
Copy and paste, right? So we now copy and paste the contents of this file, which are all the declarations, which is the minimum amount of information I need to know to call the function, over here into main. And so now when the compiler is compiling this file, it's like, oh, I know how to call all of printer. I know how to call any of printer because you've given me the declarations up here, right? If I get rid of this line, give it a second, it's like, what the heck is an integer vector? And I try like building, it's going to complain about like all kinds of things. Like, I don't know what an int vec is. I don't know what all of printer is. I don't know what any of these functions are because you haven't given me the declarations.
file with all the declarations.
Correct. Well, no. So you're correct in that you put all of your declarations in the header file. Anywhere you want to use any of these methods, include that file there. So if I wanted to, since I'm also want to be able to use some of these methods in here in the CPP, I include the header file as well. If I had some third file that wanted to make use of any one of these functions, I would also have to include that file there as well. For example, over here you can see that I include printers.h, right? And printers.h, or not printers.h, I should say printers.cpp also includes vector helper, and I need to include vector helper so I know how to print it out to the screen. So since I wanted to use this function, the overloaded outstream operator on vectors, inside of printers.cpp, I had to include it inside of printers.cdp. Because I don't decide to use it over here in main, right? I don't try to print out a vector directly. I don't use that method directly. I don't include it here. And I also wouldn't need algorithm in this function as well because I'm not using it. Yeah. So the question is, what are streams? Streams are an abstraction for representing a sequence of characters, more or less. So an example of where you can get a sequence of characters from would be a file, right? You could read it like character by character. Another example of where you might want to read a sequence of characters from would be the keyboard, right? As the user types them, right? But you know, a file and what the user types are very different things, right? But they're all kind of both input streams. An output stream is something that you can write characters to. So you can potentially write characters to an out file or to an F stream, right? You can also write characters to the screen. So they're a generalization of that concept. Any other questions? Yes. So the project name, like what does this do? So you don't need the same project name, you need the same executable name, which is defined right here. Right? It just so happens that for this project, the executable name is the same, algorithm, right? But I can have a different name here. If I call this guy Bob or whatever, now the executable that I'm going to produce, hold on a second. Oh, my bad. Gotta change this line too. Oh, many B's, yep. And now executable that I'm going to produce, which you'll see over here in the build directory, if you give it a second, or not the build directory, the CMake build debug, you can see I created a new executable whose name was Bob, right? So this line right here controls what's the name of your executable that's going to be produced. And it is possible to produce multiple executables from a single project by compiling different parts of them together, right? But this would be like the name of my project. This is the name of the executable I'm trying to create. This one right here has to be the name that I specified in the assignment. Anything else? Yeah. Yes, argv0 is the name of the program. It does count as one in the argument count. So if you just say, you know, like / my program name, or you just run your program name with no command line arguments, argc will be 1 because you're always going to get the name of your program. Yeah.
All three homeworks, one file for each.
When you submit each one separately. So you zip like top common words, everything together, and submit to the top common words. Everything for rock, paper, scissors, zip that together, submit for rock, paper, scissors. Anything else? Okay, then, if you guys don't have questions, what I want you to do is try to apply your knowledge. And what I want us to do is write split. If you guys have never used split before, what it does in Python is you have a string and you say, I want to split this string on some substring. And what you'll do is it'll break apart that string everywhere that substring occurs. So we get B, 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 B. Oh, here's our first A, so we split. So we get B, 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 B. Then we have another A right away, so we just end up with nothing. And then another A right away, so we end up with nothing. Then we have C, 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 C. And then, again, we break apart on the A, and then another C. By default, split splits on white space. Does that make sense? How it behaves? If there was no split character, for example, if I just have something like, you know, bob.split on Alzi, we just get Bob. So I want you guys, where is this? Think about how we would end up writing split over here in more string functions. So the first thing to think about is what would split return? What's a return type going to be? A vector of And right now it's complaining about vector. Why is it complaining about vector? Because we haven't included it, right? If we want to be able to use it, we got to include it. And what should we attempt to split? String. So std : string. Or should its type be different? A reference, so just be a regular reference. A const reference, because we're not planning on changing it, and we don't want to copy it. Oh, wait, we need one more argument, I guess. So we need another const std : string reference, delimiter. I always spell this word wrong. So delimiter is the string that we want to break our answer apart on, right? And so if we have something like notice that it splits on the entire substring, so it breaks it apart by half. Or even like a more common usage is hello class, it's nice outside. And then if we just do dot split, it will split on white space. So each of the words is broken up. So I think split behaves slightly differently if we give it white space by default. Because I'm pretty sure if I do space, 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 I just get hello class. One before you saw I did a, right? And there got these little blank spaces in between. So we're going to more go towards this method for everybody than this guy over here. But we could potentially provide an additional argument. It'd be called like, collapse delimiters, where we could get this behavior as opposed to this behavior. So if it was true for collapse delimiters, we would get this. If it was false, we would get this kind of behavior. We'll start with the first one. So what should we do first? Iterate, and what are we trying to do? Okay, so think about, what's the word you just said? We're trying to find the elements. So what should we use as opposed to iterating ourselves? We could use an iterator, but also find, right? And so there is a find that's a little bit different than the one inside of algorithm defined on type of strings. So if we look at string over here, you can see that they do also have a find method defined on them. And find can accept another string, right? You can also give it a position at where to start at. So how far into the string do you want to keep searching from? And it will return the position of where it found that guy at. So it returns the first position where it found it at. So we're going to need to keep calling it. If there were no matches, it's going to return string npos, string no position. So we do need to iterate, but we should iterate smartly. So pause. So something like for pause, so we want it to be equal to string dot find delimiter, right? So we want to find where that position's at, right? We want to keep going for how long? Until we don't find any more of that, right? So I want to keep going while pause doesn't equal std npos. And then the next time you want to get the next string, std : string : npos. And then for our update statement, we get the next one. And I think I took, this should have been right here. Right, so a lot of times up until now, we've seen a lot more like simpler initializers and simpler update statements, like initializer equals 0 or equals begin, right? Now you can see you can set it equal to the result of a function. And then for update, we also made it equal to the result of the function. But maybe this should be a little bit different than pause equals string.find delimiter. Each of these also needs to be updated, but we can talk about this maybe on Monday. Because we need to say not to start searching from the beginning of the string each time, which is what we're currently doing right now. We need to say to search from the next spot in the string. So we need to know like how long the delimiter is, right? And then where we're currently at. So in rock paper scissors we use both the command line and the standard input. So in the command line you get the seed. From standard input you get their choice of rock, paper, or scissors, and also whether they want to replay the game or not.
Okay. So when we turn it into Python, should we just have it as a command line or like?
So again, you need to get input from both sources.
Okay.
The seed comes from the command line. Everything else comes from standard input from CN.
Okay.
That seed just to make sure we get like the right results, so it's not.
So again, it's like we said that it's useful to use a constant seed for testing. So you can compare my answer against your answer. We have to use the same seed. Because if we use different seeds, we're going to get different answers, and then even if you're doing everything 100% correct, right? It looks like you're doing it wrong.
Okay.
Even though it's right.
Thank you.
Thank you. Well, yeah. As soon as people stop talking to me here, yes.
Okay, cool. 'Cause I have like a problem with segmentation calls.
Yeah.
I'm trying to create like a vector of string, but it's complaining that it is
Constant too long for its type. These should be double quotes, not single quotes. Right? Double quotes are for single characters.
oh
Right? The single quotes are for single characters. Double quotes for multiple characters.
Okay.
For strings. Yeah.
You said you can format your stream into any type, or
You could read formatted input of any type from a stream.
okay.
I guess that's the more technical truth here is you can read any input from a stream as long as it has like an input defined on it, which all their basic types do, minus vector.
I guess my question was really about
Okay, yeah.
that, but like, so we read for our homework, we read the stream from the text file. I can format it into a string, right?
Yeah, and then would read out like word by word.
Okay, so there's no need to get line.
No, because you don't want an entire line. You don't want to process the file line by line, right? You want to process it word by word.
Yeah.
So it makes sense to just have a string that you read from that file into that string.
And then I haven't really implemented it yet, but I was thinking, so my math would be like, the keys would be like frequencies, like numbers.
Yeah, so you're going to have the keys be the frequencies and...
And then, so I know that if a certain set of words have the same frequency, I need to arrange them alphabetically. So then, is there a way to like have like sections of math of the same key value and arrange those?
So what I would recommend is, because if you want to do what you're doing right now, you'd have to be using a multi-map, right? You have multiple of the same keys. Let's say you weren't using a multi-map, which means each key needs to be unique, right? So you could still have the keys be the frequencies, but what would the elements need to be now? Since you need multiple things there.
The elements of each key are the word, right?
Well, but again, you said you need multiple people to show up here, but you're not using a multi-map anymore.
So it would be like a vector?
A vector of strings, right?
Yeah.
Then if you had them all in that vector of strings and you wanted to sort it, you can just call the sort method from algorithm on it.
Okay. So then, so math, this would be my, each math I as my vector of strings.
Yeah, so you have integer to vector of strings would work. But you may need to, at the very beginning, start out with a map that goes from string to int, so you get the count of each word. Because you want to know how many times each word appears. Then once you know how many times each word appears, you can kind of like flip the map. Then it goes from counts to words, goes to words to counts. Yeah. Somewhat.
Yeah, you have to send me an email, bro, so I can have a reservation address. That's fine. Yeah.